In this video, we're going to talk about the various parts that encompasses a Viking 130 engine. We're going to talk about seemingly unimportant things that together make up for what we believe is a high-quality aircraft engine. We're going to talk about things like the gearbox. We're going to talk about things like the prop hub, lugs on the prop hub, the type of starter that we use on these engines, the molded intake manifolds, the variable valve timing, the direct injection fuel pump, the type of alternator we use, and a host of other things that are encompassed on this engine. We're going to describe the Viking 130 engine in detail. Details is what makes a quality product. Anyone can have an engine that has 4 cylinders or 6 cylinders and operate. It's a whole other thing when you start looking at what's under the skin of the engine per se and what it is put together of. So let's look at that together as we explore the Viking 130 aircraft engine. Now up front on the engine you'll see the propeller drive or the gearbox. Some people call it a PSRU, Propeller Speed Reduction Unit. Basically it's a box, CNC machined, with gears in it that has the proper inputs and outputs to drive a propeller with a torsion dampening system. Here's the inside of one. It's basically, some people have like this fear of the PSRU, the Propeller Speed Reduction Unit. It's this magic box up front that drives the propeller. I wouldn't have that fear if I were you. I would just think of it as a very simple transmission. It doesn't have any shifting, it's not automatic, it's not even manual, it's just one speed. Meaning that there's power coming in, it goes through the gears, and it goes out to the propeller. So it's not very complicated, just has to be done right, because aircraft engines do operate under quite a bit of power output consistently. The way you can tell if a gearbox is running properly is through a sight glass, which we have on the side of the gearbox, and there's gear oil inside here, and on pre-flight you can view that sight glass, and you can see that the gear oil is nice and clean. You can also monitor the temperature during flight to feel secure that the temperature is the same as it's always been before, knowing that a bearing is not going bad or a gear is not wearing down or something like that. So there's plenty of warning to a pilot about a gearbox if it's properly designed and implemented on that particular engine. Now, looking inside, just to have something, just showing you the inside, this doesn't have any gears in it, but it just shows you how it's laid out with a large heavy-duty ball bearing at the bottom for the high-speed end, and then roller bearings where the loads are much greater as soon as the RPM decreases and the torque is stepped up, and then dual bearings and more bearings in the aft housing for the propeller. Now, looking at the gearbox a little bit further, when we focus on the engine, we see that there's also a backing to the gearbox, which is properly mounted with large bolts all the way around it to the bell housing of the engine. Up front is a propeller hub that drives the propeller. Now, next we could talk a little bit about such a small part, which, if done right, would make your flying career with an automotive conversion very successful, or if not done right, could be a bad day. Here's a quick point about something that obviously is important. You need to understand that these engines produce a lot of torque, and that it is not kosher to have a propeller flange with a hole pattern for all different kinds of propellers, where you would just put bolts in, variety of holes. If you got a bigger prop, you put the holes out here. You need to have a propeller hub that's designed to carry the load of the engine at hand. And the most important thing is that it needs to have lugs in it. Lugs are used to take the shear load of the propeller. If you don't have lugs, you just have holes in the propeller disc, that shows that the design is not optimized and the load of the propeller is on the bolts. Now with the lugs, all the loads are on the lugs. They're much beefier than an 8mm bolt, for instance, and they can take that load with ease. Value. I want to just keep showing you value, as in, you might say, well, why am I showing you all these things? But I'm showing you because I want you to understand that there's value in buying a mass-produced Honda engine. Now, here's a picture of what you can have in today's world for a starter motor, for instance. You can have an aftermarket, probably Asian-made starter motor for $65 that'll fit a whole lot of engines. You can have one for $50, $60, $70. This one is used on a Suzuki. Just an example, printed that out. So it's aftermarket. It's new, but it's junk. It's aftermarket. Or here on this Viking engine, we know that Honda does not want to have cars stranded along the road, at work, in the morning when you want to go to work. You want your car to work. So the modern approach of auto manufacturers is to make sure that there's quality behind the accessories that are on your engine or on your car. You'd be unhappy if your starter didn't work. You'd be unhappy if your windows didn't go up and down and all that. And they know that, and they get reported on that for Consumer Report. So they will have a proper, nicely made, either in the US or in Japan or other reputable countries or locations where parts can be manufactured that are not made to be the absolute cheapest. They're made to be the latest in technology, efficient, a lot of torque, yet you can get this starter rebuilt at an auto parts store anytime you want, or you can get the one that comes with your engine, which is a genuine Honda starter, and it will be the right thing. It will be the right starter for the right engine. It will be available all over the world, and surely later on, if you wanted to get an aftermarket new starter, you could, but it's not what's shipped with your engine. It's a genuine Honda starter that was designed for the engine and designed for the car that the engine came out of. And while we're on the topic of accessories, or the main accessories, of course you get the starter and then you have the alternator. The alternator is the same thing. Surely you can get an aftermarket alternator for $90. You can get one for $60. They won't last. They might last 40 hours. The problem with the aftermarket alternators is not that they fail mechanically or that the bearings fail or anything like that. The problem is they don't have the electronics that can take the temperature. There's voltage regulators and electronics in these alternators that, unless it's a genuine Nippon Denso Japanese built alternator, it will not last nearly as long. Now granted, a true Nippon Denso or Mitsubishi or high grade new alternator is very expensive. Now Viking we have our own part number with Denso, and it is an alternator that's made in Japan, and it is a 40 amp alternator. It's an alternator that's similar to what you would find on a John Deere tractor or a Kubota or something like that, where the list price would be close to $600. Now we're not trying to tell you that you need expensive parts on your engine. We're just trying to tell you that there's a difference between the true Nippon Denso brand and something that doesn't have an embossed ND on it, that would be a clone or a copy that if you search for it, you could find for $49 on eBay. But I guarantee you, having been in this business for over 30 years, it will not last. So look for the Nippon Denso brand. Those are the ones that are these tiny little lightweight alternators. You'll find them on certified planes too. They're conversions available, but they only use the good type of alternator. You'll be able to tell because if you look through the fins, you can see the gray ceramic coating. You can see the raised Nippon Denso embossed symbol, and generally the quality of the fit and finish of the casting is superb to the aftermarket ones, which other auto manufacturer or auto conversion companies do use, and they are new, but you get what you pay for. Alright, let's just kind of go through this a little bit at a time. Talking about, I want you guys to know that we're not just selling you something that, was cobbled together. And I want to actually show that to you, because a lot of times people feel like, and some other salespeople that are selling other brands of engines, that make a big point of that, well, you know, if you want to go with the least expensive, as in, you know, an auto conversion, you get what you pay for. Now, of course, we don't believe that, and we know that, and we would never sell you that. So I want to actually show you what you get. Now, these are gears, or a gear, that is inside the gearbox that you would get mounted to your Viking 130 engine for your airplane. So now, what you're looking at here is a $600 gear, and there's 3 of those in your gearbox. They're forged, they're the proper steel, they're ground, shot peened, hardened, everything that a gear should have in order for it to last as long as it does in any kind of a large General Electric turbine, or a big radial engine, or something that takes a lot of load all the time. As you can tell, they're helical cut gears. They're hollow in order to have lightweight, and like I said, they're forged. They have all the bearing lands that are properly sized for the loads of the propeller and the gearing and the horsepower of the engine, and obviously the splines that are carrying the loads of the propeller hub and the input drive coupling that are associated with the engine. So these are just one little piece that make up your engine, that has a lot of cost, because it has to be absolutely professional, and that's the only way we would deliver an engine to you. Now, there's a lot of things we can talk about the inside of a Honda engine. I want to point out some of the features that you might not be aware of. A lot of people have worked on engines as they maybe grew up, or worked on 2-strokes, lawnmowers, maybe some V8s, hot rods, whatever, but there are new technology that goes on in the engines that has made engines able to rotate faster with less friction, and then operate for hundreds of thousands of miles without any internal engine problems, which is totally opposite of some of the conversions being done today out of old engines or aftermarket parts that don't have this type of internal technology present. Here's a sample, for instance, of some parts that I just brought. They're actually not a Honda piston, but we rarely see a Honda engine apart. But it does have the same technology, so I can actually show you what it is. It's what they call the fractured connecting rod. A fractured connecting rod means that it is all made in one piece, the entire connecting rod, and then it's frozen, and then they share it. And the advantage of that is, when you put it back together, it will have an absolutely perfect fit, because it will fit in the same microscopic grooves of where the part was prior to sharing it. Let me put it up on the camera, and maybe you can see the details that I'm talking about these parts. So as you can see, it looks like a crater actually when you get that close, and it shows you the technology that allows the parts to go together as though they were never taken apart. Just another thing about modern technology that didn't exist, and some people sometimes ask, you know, how can these engines operate at this kind of RPM and this power output for so long, yet being an automotive engine? And I'd like to just show you some of those things. In focus, you see our torsion dampening system, which is crucial for an auto conversion to operate properly for hundreds of hours. Flying across the country like we do, we've never had an issue with this. We had issues with our earlier engine that had to be beefed up, but once we started with the 130 and then improved on what was on the 110, it's been a very, very successful and nice system. We run a German-made torsion dampening coupling, and it is a floating design where it's not bolted down. It allows it to ride on the pins. It makes for, if you ever wanted to pull the gearbox from your engine for any reason, it basically just pulls right off and goes right back on. So it's very good as far as maintenance. If you ever wanted to replace those rubber couplings, maybe after 5-6 years, it would be a matter of quickly removing 4 or 5 of these larger bolts and spacers, put a new dampener on, and torque it back down with a new centering bushing in the center. So it's a very nice system. It's easy to inspect, and it doesn't use an inexpensive aftermarket rubber coupling. It uses the original German-made coupling, which is used in the industry by a lot of people. They're used on Mercedes cars, they're used on BMW cars, they're used on Corvettes. We have our own tweak on the design where we particularly tune the dampener for different engine sizes. It's not a one size fits all. A lot of flight testing has been done in order for the dampener to work at idle, for it to work at full power, for it to work when you cut the power and you're gliding. And just like when we were over and talked to Alex when he flew his seaplane with it, he said that the tuning of the system between the engine and the propeller was the smoothest that he had experienced, both during startup, shutdown, and in flight. So it's a very nice system, and we're very proud of it. And here's the other side of the engine. Here you can see what we talked about, but an integral oil pan that's part of the engine. Structural, there's your oil drain plug. Now you can drill that and safety wire it if you'd like. Here's something that's important. Of course, there's a piece of paper over this now, but you also do see the exhaust gasket. This is the only exit on the engine for exhaust. The 4-into-1 is done in the casting itself. It's an efficient system that Honda came up with. What that does for you is, of course, you have studied other airplane engines, and you see that particularly the horizontally opposed ones, their exhaust pipes going everywhere from each cylinder. They all have to kind of come together, go into mufflers, and then go overboard. On this system, this is all done internally, which makes it easy to inspect, less chance of leaks and breathing carbon monoxide. And it's just a muffler that bolts on here with a tailpipe that goes out the belly of the airplane. So it's very straightforward and simple. Now it might look cool with like a stainless steel, all kinds of mandrel bent pieces that are welded together, but picture it as a practical thing. You want to be able to fly this engine. You don't want to keep looking for exhaust cracks. You don't want to have to find out who's going to make your next exhaust manifold. And all the heat that's being placed into your engine compartment from this huge manifold. So keep in mind, simple is best. A couple of things that kind of stand out just looking at this engine. And we do tend to now compare ourselves more with other auto conversion companies. And the reason we do that is because we live in America, there is competition. There's also what's fair, and trying to be straight with people and give you the information correctly. Now what you're seeing here, let's just point out a couple of things. You're looking at an intake manifold, okay? It's a resin manifold, it's a molded manifold. It's done that way for a lot of reasons. Now, you look at an earlier 4-cylinder engine of similar design but kind of older fashion, you'll see a lot of aluminum parts, die cast and sand cast and aluminum parts. So, of course, a cast manifold, even though it might look okay for aircraft use, it's cast, okay, so it's heavy. Any air that goes through, it's going to be heated by the metal that's been heated because the engine is equally hot as the manifold. The things that are less apparent are in the details. Those aluminum manifolds have a flat gasket against the engine, which means you bolt it down, you might put a little bit of goop on each side of the gasket, and you assemble it, and it becomes really old-fashioned because now when you remove your intake manifold, it's like the old cars. You got to scrape gasket material and all that kind of stuff. When you look at the real details of this manifold, you'll see that there's hard points put in, brass inserts and things like that. There's silicone O-rings that are in every port so that when the intake manifold goes on the engine and is removed from the engine for any kind of maintenance underneath the manifold or checking something, there's never any need to replace gasket or scraping gaskets. You just put the silicone O-rings in. They're good for the life of the engine. You can pull the manifold off, put it right back on. So it's just all around a more modern approach to serviceability of an engine. Looking down here is something as simple as an oil pan. Well, oil pans used to be made inexpensively out of pressed sheet metal, usually black powder coat. Honda uses cast oil pans. They're structural. They're integral to the engine, so it gives the bottom end even more structure. And they don't leak. They are machined. They have a perfect fit to the upper part of the engine, the block of the engine. And basically you can't strip the oil plug. The filter is incorporated in it. It's, again, something that car manufacturers have learned, and maybe very important in an airplane engine where you do service it more often. You take the filter off more, you take the oil plug out more than you do in a car. So having a cast integral oil pan is important. Now, just keep looking around on this engine. You see that also the intake valve cover is a resin or high temperature plastic. It's the same thing. It has a molded gasket that goes in a groove that doesn't leak, and that if you take the cover off to do an inspection of your valves on an annual inspection or every 2 years or so, you basically just use hot water and soap and clean the rubber or silicone or combination gasket in your sink and stick it back in the groove. Put a little dab of sealer in a couple of spots where the casings meet, and then put it right back on. The other thing, of course, is coil unplug ignition. You will see people of older designs retrofitting or putting dual coil packs next to the engine and then running spark plug wires to it. The problem with that, of course, on a 4-cylinder engine is quite large, because if one coil pack goes down, you lose 2 cylinders, which of course you don't want, and this is a major one. If a coil goes back, you do want to lose just 1 cylinder. Then you still have enough power to fly around and come home. That doesn't mean that that happens often. This is something that 10 years ago, 15 years ago, it might happen that you have a coil failing because it gets hot on a car engine. Modern engines, they've learned a lot about how to do this. Their resin cover with the single screw that holds the coil to the plastic. There's no real heat being transmitted into the coil head, and because of that, they're very reliable. And the coils are individually on top of iridium/platinum spark plugs. That combined with a proper wire loom that is done with the proper crimp tools and the proper pins and the right tough cell wire, like we talked about, makes for a very reliable system. These are details that you really need to study if you're looking for an auto conversion for your airplane. Let's also talk about piston speed and reliability and RPM. A lot of it is a discussion about if your particular engine has a lower piston speed, or it has something that favors, maybe that's what you market. Of course, the true story is that you cannot say anything about Honda's design or engineering about 4-cylinder inline engines. There's nothing you can say to anyone about that they have an engine that is not as efficient or as good or technologically advanced or appropriate for high RPM as anything else, particularly something that was designed 20 years ago, which these Honda engines have evolved and they're not. Viking uses 2019 and now 2020 technology engines, and there's a vast difference in 20 years of R&D that's gone into car engines. So someone that's talking about that somehow their older design is better for aircraft is not true. Now, RPM, let's talk about that. Forget about piston speed, forget about friction, forget about everything. Let's just talk about RPM. Most people that we talk to, one of their most popular questions is, can I run that kind of RPM consistently in an airplane engine? And we're kind of like meeting you halfway on that. There are companies that run their auto conversions in the 6,000 RPM range, 6,600 RPM. They have gearboxes that have 2.5, 2.6 to 1 ratios. And that's really getting into like two-stroke territory, which we don't want to be even close to. We want to be a four-stroke alternative to the traditional engines. We want you to be able to cruise down in the 3,000, 4,000 RPM range, and maybe peak power at like 5,400 for a very short time. So we have no business of going up into the 6,000 RPM range, and we feel you should feel the same. What happens with after you leave like 5,200 or so, even in a well-balanced engine, four-cylinder, it becomes a magical number where you can advertise horsepower because you have a gearbox that allows you to really turn this engine up. But once you start flying that airplane, you start thinking, there's a lot of fuel going through this engine because of the inefficiency of the higher RPM. The noise is much greater than I thought. I keep having to balance the propeller all the time because overall, the engine running at that RPM and all my accessories running at those higher RPMs just doesn't feel right. So if you can buy an airplane engine that takes off maybe around 5,000, maybe even 4,800, and you can cruise it at 4,400 or 4,200, that's where you want to be. So be careful about the gearbox ratios. Don't buy engines that are based on high RPMs. Like, I got a little engine and I'm getting 100 horsepower out of it and it's only a 1 liter. That's not where you want to be. You want maybe not to go all the way back to like a direct drive Lycoming that has very low RPM and a lot of power per pulse, but you also don't want to go up into the two-stroke RPMs. So that's where we kind of shine because we've been doing this for so long that you end up having an RPM that just feels right. It's got the right sound, doesn't use too much fuel, and the propeller turns at the proper RPM. So how about variable valve timing versus fixed valve timing? Obviously, the modern car engines uses variable valve timing, and companies have learned that it's not complicated. There's basically a sprocket on the back of the camshaft, on the intake camshaft, that varies between the shaft itself using oil pressure and a solenoid, which is very easy to control by the computer. Now, is there any advantages in having variable valve timing on an airplane engine? Of course there is. The argument sometimes is, well, airplane engines run at the same RPM all the time, which isn't true. I mean, you cruise at 75% and takeoff, you want 100%. In fact, you'd maybe want a little bit more than 100% sometimes. So you want maximum efficiency and power and torque at cruise, and you want all the horsepower you can throw to the propeller at takeoff. And sometimes you want to just loaf around and look at the terrain down below you in maybe high wing zenith and looking out the window. And you don't want the engine to be inefficient down at 3,800 RPM either. So obviously it has an advantage, just like it does in the car. And we implement that. We use the technology that's in the engines, that come with the engines, because it's simple to implement, it's not complicated, and we see the difference. For instance, we did a video maybe a couple of months ago now with Alex over at with the Aventura airplanes, which we happen to have one ourselves now. Nice little airplane. And we actually demonstrated that the Viking 130 was able to run at a considerably lower RPM in cruise compared to other auto conversions. And we found that the fuel flow, the noise, and just the overall feel of the airplane was so much more pleasant because of the lower RPM and the increase in torque that we were able to achieve. There's been write-ups about what's superior in an airplane engine, single overhead cam, dual overhead cam. The argument has been like single overhead cam is lighter. So usually someone would push their argument because that's what they have. Now, I'm going to give you both sides of it. The single overhead cam is maybe simple, but it is older technology. You don't find it in efficient car engines anymore. Of course, a single overhead cam or camshaft was back in the 90s when camshafts were solid and they were heavy, basically a hunk of iron. So they're heavy. They're not lighter like dual overhead camshafts of modern design that are hollow camshafts with pressed on lobes and just overall more efficient because they're working directly onto the valve rather through heavy rocker assemblies. So between the rocker assemblies and the cast solid cam shafts, the dual overhead cam is lighter and more efficient.